In this lesson, we're going to learn how to graph linear inequalities. First of all, linear inequality is a region. It's a whole space, sometimes referred to as a half-plane, composed of many points. The boundary is a line. Now, the line can be solid or dotted, depending on whether or not equality is part of the symbol, or if equality is not part of the symbol that you have. A point from a region that gets substituted into an inequality will make a true statement. Let me show you what that looks like. Here's a graph of an inequality comprised of a dotted line boundary, dotted line because there's no equality here, and the shaded region is underneath. Now I've chosen a few points, 4, 1, and 0, -2. If I check those points in the inequality, substitute 1 in for y, and substitute 4 in for x, we'll see that I have 3 and I have 1, and this would be less, and that inequality was less than, so this makes a true statement. If I substitute 0, -2, similarly, I would get -2, and I would get half of 0 and 1, so I compare -2 with 1, and -2 is less than. So again, it's true. These points are in the region, so they satisfy the inequality. That's an important tool that we're going to use in a bit. Now, how to graph an inequality? Well, you start with the corresponding equality. So consider 2x and 5y equals 5. Isolate for y. Show the y-intercept, the slope down 2 and right 5, or up 2 and left 5. Alright, that's the boundary line. Notice that there's no equality, so I'll be making a dotted line boundary. Like that. A ruler would be a good idea, I guess. And now I'm going to try a test point. It's either below to the left or above to the right. I'm going to test 0, 0 and see if it works. 2 times 0 and 5 times 0. Well, that's 0. 0 greater than 5 is false. So 0, 0 is in the wrong region. The region that I want is the region up above. So I'm going to shade this whole space. That's the graph of that inequality. So again, what we do is we start by graphing the equality, deciding whether it's solid or dotted, choosing a test point, substituting the test point, looking for truth or false in the expression, and on that basis shading either the region that we chose because it's true or the other region because it's false. Next, a system of linear inequalities. Now, a system of linear inequalities is basically two or more of the processes that I just did. So here's an example. What if I wanted to graph 2x minus 5y less than 5, which, by the way, can be rewritten as y, let's show the work here, -2y plus 5, so y greater than 2/5 x minus 1. So y-intercept of -1, slope of 2/5, dotted line because it's not equal to. Alright, testing the point 0, 0, which is what I usually choose because it's easiest. I would get 2 times 0 minus 5 times 0, or 0 less than 5, which is true. So 0, 0 is in the region, so I want this whole area over here. Now, if I add a second inequality, like x plus 2y greater than equal 4, or 2y greater than equal -x and 4, or y greater than equal -1/2 x and 2, a y-intercept of 2, a slope of -1/2, and this has equality, so I will be making a solid line through these points. Again, I'll test 0, 0 because it's convenient. 0 plus 2 times 0 0 greater than equal 4 is false. So I don't want the region below. I want the region up above here, like this. Now, considering that it's a system, what I want are the answers where these are in agreement with each other, where they're both shaded. So I'm going above the red line and above the blue line. So the boundary is here and then here. All of this region satisfies both inequalities. You may want to pause and just consider that and make sure that that makes sense for you. I could also be asked the reverse. So I may be given a graph representing a set of inequalities and need to come up with a description of them. Let's name these A, B, C, and D. First of all, equation A is horizontal, so it's a y equals equation. It passes through the point 0, 4, so it's y equals 4 for the equality. Now, it's below, so I want less than as well as equals because of the solid line, and 4. There's one answer. Line B has a slope of up to right 4, so a slope of half, a y-intercept of -1, so y equals half x minus 1. And now let's erase the equality, and what we're dealing with is above the blue line, which includes 0, 0. So if I substitute 0 for y and 0 for x, I would get 0 related to -1. And this needs to be a true statement, so I'm going to say 0 is more than -1. So taking the equality part along with the inequality I just got leads to greater than or equal half x minus 1. I'm including equals because this is a solid line again. Line C. Okay, line C has a slope down 5, right 5, so a slope of -1, a y-intercept of 5, an equation therefore of -x plus 5, and again for the red line representing C, 0, 0 is on the side that's being shaded, so 0, 0 will form a true statement. 0 compared to 5, 0 is less than. So putting the equation together with the inequality leads to less than or equal -x plus 5. I'm just going to box the ones that we found so far. So we've now found 3 lines. I found the lime green one. This second one represents line B, or the blue one. The third one is the red line. And the fourth line, D, well, that's that vertical green line. Vertical lines are represented by x, and the x value is 0, and I want values to the right of it, so I'm going to say greater than or equal to 0. These 4 inequalities represent this region bounded on the left, above, to the top right, and to the bottom right. Now there's one more I just realized here. Actually, you know what? I'm going to shade this. I didn't mean for that. I meant for that to be shaded. There we go. Otherwise there would have been a 5th line along y equals 0. Anyway, that's the basic idea of how to work with systems of inequalities that are lines.